Hi guys, welcome back to the channel, and today I'm going to be talking about DSU, or Disjoint Set Union, or as it's also called Union Finder. So as you might be able to guess from this name, it is about finding the union of different vertices in a graph. So the idea is that you can have a graph, and it will keep track of the connected components, the size of those connected components, and it'll be able to identify if two elements are in the same connected component or if they're in different connected components. Also, it will be able to rapidly adjust this representation. So let's say in this case, I have four. I have four elements, or I have five nodes right here. So right now, there is five connected components. If I connect these two, then now there are four connected components. And I have to make sure that these two are known to be together, and that I can tell that these two are part of the same connected component. And I have to have a way to check the size of this connected component. So now let's say I do this again. Now there's two connected components with size 2. But if I connect these two, now there's one big connected component of size 4. So the way that a union finder works is it keeps track of the parent node for each connected component. So let's put some numbers on these. This is 1, 2, 3, and 4 and 5. Currently, the parents of all of these nodes are themselves, and the size of each of the connected components are just 1. But if I connect these two, then now the parent of this is itself, but this parent has changed from 2 to now becoming 1. And now this has no connected component associated with it, so the size of this connected component is 0. And the size of this from 1 has now gone to 2. So if we want to find out, let's say, the size of the connected component that 2 is in, first you have to find the parent of that connected component, which is 1, and then you have to get the size of that, which is 2. So now we can do the exact same thing for this one. If I connect to 4 to 5, then this will stay at 4, this will go from 5 to 4, and now the size is 2. Now, let's say if I connect these two, what's happening is I'm merging these two connected components. So what needs to happen is the parent for all of these has to be altered. So the way we do that is here we have to find the parent of this node, which becomes 4, and the parent of this node, which is 1. So now what we do is we pick one of these, and we say, and let's say we pick 5. Now we set the parent of 5's parent to be the parent of 1. So here what we do is we set the parent of 4, we set it to be 1. So now this is all connected. And we also have to update the size of the connected component. So we just take this parent and sum the size of the connected component to here. So now it's 4, and this becomes 0 like the rest of them. And now this connected component is 1. So now we have this connected component. So one thing that you might notice is if we keep on doing these additions, we might have some inefficiencies. In this case, where it's just 2, if you want to find if 2 and 1 are the same connected component, you only have to do one jump to get to the parent. But now for 5, you have to do multiple jumps. 5's parent is 4, okay? Its parent is 4. And now we go to 4. 4's parent is 1. okay? So now we go to 1, and now 1's parent is itself, so we have it, right? So the way to make this more efficient is that every single time that we do a query, make sure to update all of the elements you go through to be the final parent. So in this case, when we go to 5, we start at 5, parent is 4, then 4's parent is 1, and 1 is the parent of this whole connected component. Now when we go back to 4, we make sure that the parent of 4 is 1. And then we go back to 5. Now, since we've done that whole calculation, we'll say that the parent of 5 is 1. And now, if you have to call 5 again, it's just a constant time lookup. So this makes sure it's as efficient as possible. So let's look at the code for this. It's quite simple. So first, we have to have these two vectors storing the information. So this stores the parent of every single node, the parent to tell which connected component is in. And this is for each parent, this vector will only be non-zero if the node is its own parent, or to say it's the parent of its own connected component. Otherwise, it will be 0. And here we're just initializing them. So to do a get just tells you it just gives you the parent of that connected component. We're doing exactly that. When count is greater than 1, that means that we've gotten to the parent of an entire connected component, and that's the final node we have to return. And so for that, you just return itself. But otherwise, you have to get the parent of your current node. So you have to go one step up. And I was talking about before, to optimize it, you set this value back to the parent of the node you're currently on, because then if we do this in the future, it's just one step. Now, one good thing about DSU is very fast to calculate if two nodes are in the same connected component. So this is how we do it. You just get the parents, and if the parents are equal to each other, then they are in the same component. Now for size, we have this count array, so that's fairly simple. You just get that. Now for the most important part is how to unite the connected components. So here we have two nodes, and we just are introducing an edge there, and because of that, you have to make sure that the two connected components that those are in merge into one. So here we are getting to the parent of those two connected components, because that's really the important part. That's really the important part of this unite, because that's where all the information is. It's where the count for how big the component is. Now, if it's part of the same thing, you just return from it because they're already united. And now you have to update the count. So it doesn't matter where you pick the first one or the second one to be the final connected component, but in this case, it's just the first one. And then for the second one, you set it to 0 because now it is not the parent of a connected component. And finally, the one that got merged, y, its parent is set to x. And now you've finished the unite. So as you can see, this code is very simplistic and easy to implement, but it's very useful in a lot of cases. For example, if you have any problem relating to merging, creating new edges, deleting edges, and querying connections, then this is very useful and very fast. And the most basic version of a problem, it would be something where you just have a bunch of vertices like this. You just have the vertices, and they will basically have queries to add new edges, and they will have another type of query where you have to find out if the two nodes are part of the same component. So normally, to do that, making a new edge is very simple, right? It's just an O of n. But to figure out if two are in the same component, you have to do a whole traversal from each node and see if you encounter the other one. And that's very slow. But with the DSU, it's much faster, and it's very useful for a lot of topics. And it's especially good because it's so simple to implement and remember. Okay, I hope you found this video helpful. If you liked it, please like the video and subscribe, and I'll see you next time.